So as some of you know, because I've already been asking you some really idiotic questions, I am pretty new to your world. Because for the last 20 years, I've been working as an international investigative journalist. And I've come to an unlikely conclusion that I believe that the jobs that you have are the most important on the planet. You have the ability to define our future, humanity's future. Let me put it this way. We now have the technology available to us to discover more of our planet in the next 10 years than we have in the last 100,000. Humankind is poised to make the next giant leap into the deep ocean. And you are the great pioneers of this journey. We all know of the space race. But of course, there is another race which is underway at the moment. The race to discover how the ocean is changing before we destroy its resilience to support life on our planet. And I believe it is the most critical journey of discovery that we can and we must undertake now. That is why the work which you do is so critical. And with it comes extraordinary opportunity and also great responsibility. Let me try and explain. As I mentioned, I've been a journalist, reporting on everything from corporate crimes to political crimes, terrorism with Al-Qaeda, slavery, climate change, and on it goes. It's been, if it bleeds, it leads. So wherever the horrible things have been going on in the past 20 years, chances are I've been there reporting on what's been going on. And a couple of years ago, I had a bit of a road to Damascus moment. I'd just come back from working in China on the North Korean border, looking at how women were being trafficked by the North Korean army across the border and sold into sexual slavery in China. And when I came back, I was sent off up to Scotland to look at a small marine protected area. And diving down, this is what I saw. It looks like an aerial shot of a ploughed field. It's, of course, the seabed after trawlers had cut their way across it. And there was this small protected area, about 1 mile squared, which was a lush forest. And as soon as you cross over, you come to this. It's as if we take a vast bulldozer and drive it across the countryside, felling all the trees, scooping up all the wildlife, destroying all the farms, just to catch a couple of cows. And if we could see that on land, there would be a public uproar. But imagine the scale of it. We now clear-cut about 150 times more of our seabed than we do of land, out of sight and out of mind. So I thought, well, hold on a minute, I'm an investigative journalist here. If I don't know about what's going on here, probably a lot of other people don't. And perhaps there's a hell of a lot more about the ocean which I don't also understand. And this is what it looks like before and after a trawl has gone over a coral reef. So I undertook a journey to try and find out a little bit more about what was going on in our ocean. Now, I'm sure that I understand there's some great scientists here, so excuse my ignorance for a moment. We all know most of these major facts. 71% of the planet is covered by ocean. Full ocean depth, 11,000 meters. Average depth, about 4,200 meters. But we've got that three-dimensional living space in the ocean, where we have at least 90%, 95% of our planet's biosphere, the reservoir of life, the area on our planet where animals can live. And we've seen these pretty pictures of coral before. And we know what's happening to the corals. That's a story which is getting out there. But there are 4 major quick indicators I want to look at. First of all, oxygen. We all like to breathe, I assume. We can each take 2 breaths now, just for a moment. That second breath is the oxygen that came from the ocean. And if you like breathing, as I do, our oceans are quite important to us. But unfortunately, oxygen minimum zones have already increased by 4.5 million square kilometers due to global warming. Low oxygen conditions activate the production of nitrous oxide, laughing gas. But of course, this is no laughing matter because the nitrous oxide is 310 times more potent a greenhouse gas than CO2. So we're starting to change the nitrogen cycle. Look at what's going on in the Bay of Bengal at the moment and the vast spread of a new dead zone up there. Look at food, for example. Over 3 billion people depend on the ocean for their basic sources of protein. But 75% of global fish stocks are overfished or fully exploited. This is a major food security issue. It's also an economic issue. $2 trillion is the cost of poor fisheries management over the last 30 years. And our livelihoods. 40% of the global population depend on marine and coastal biodiversity for their livelihoods. And 50% of marine species are predicted to be on the brink of extinction by 2100. We have already created the conditions for the next mass extinction event. Heat. 93% of all the anthropogenic heat we produce has been absorbed into the ocean. And that heat drives thermal expansion. So 70% of sea level rise is caused by that thermal expansion of the ocean. And when 13 of the 15 biggest cities on Earth are by the coast, this becomes pretty significant to all of us. The ocean, particularly the deep ocean, is the beating heart of our planet. It regulates our climate, our planet's chemistry, our water cycle, the carbon cycle, the nitrogen cycle, on it goes. And you don't have to be Einstein to know and work out where this is heading. How the ocean changes affects our climate, our livelihoods, our food security, our homes, our resources, the atmosphere, the carbon cycle, even the oxygen that we breathe. How can we make informed decisions to secure our future unless we really know what is happening? And when I came across this publication, which explained how little we actually know about the ocean, I was physically sick. I felt physically sick. Because the most important part of our planet is the least known part of our planet. And I know it's not always about people, but this will help put things in perspective. We spent 12 people have been to the moon. We spent 300 hours on the moon. We played golf on the frickin' moon. We put a flag on the moon. But only 3 people have ever been to the deepest part of our ocean. We spent 3 hours in full ocean depth. So here's the challenge that we face. The ocean, particularly the deep ocean, beneath 200 meters that makes up most of it, is the most critical part of our planet. We don't know how healthy it really is. We don't really know its function. We don't know what the impact is on the changes that are underway. And we don't really know its resilience. So how can we make these political, economic, and legal decisions about the ocean that need to be made to fundamentally secure our future if we don't know the health of our planet's heart, how it functions, its health, or its value to us? Simply, we need to radically accelerate our understanding of how the ocean is changing. We need to explore the last great frontier on our planet. So now a little bit of good news for you. As you all know, AUVs, ROVs, sensors, the base DNA, initial library of DNA sequences that we have of marine animals, all that and more, and these technological developments are now unlocking extraordinary new research capabilities, the access to new knowledge. We now have the ability to discover more of our planet, as I said, in the next 10 years than we have in the last 100,000. In the last 2 years, we have gathered more data on the oceans than in all the previous years combined. On our missions, we use a whole array of different tools. Our mission is to investigate the health and the state of the ocean. Multidisciplinary scientific teams across ocean chemistry, geophysics, biology, genetics, on it goes. And as I'm a submersible pilot, I can tell you that the new cutting-edge submersibles that we use are very useful. The immersive transparent pressure hulls, which I'll talk about a little bit more going forward, provide a unique perspective for surveying and sampling. And at certain depths, they're the best tool, particularly in the rugged terrain of the deep ocean and the complex habitats that often have challenging topography, down to about 1,000 meters where we use them. And I'll tell you a little bit more about those extraordinary tools in a moment. So where have we got to? The deep ocean is the most important part of our planet. It's the least known part of our planet. We now have the technology available to us to discover more of our planet in the next 10 years than we have in the last 100,000. And we're about to take the next giant leap forward. But despite all the awful things which I've seen over the years, I am extremely optimistic because we now have an opportunity to change course. So let's look at that big picture again. Throughout human history, exploration has driven our progress. Lief Ericson's journey, for example, to North America, the discovery of the New World, Magellan's first circumnavigation, even these gentlemen, or this one, William Beebe and Otis Barton, the first two people ever to descend into the deep ocean in the 1930s off Bermuda in that extraordinary contraption. I don't know about you, but I wouldn't want to go anywhere near that. And even, of course, space exploration. Each of these journeys have pushed back the frontiers of our knowledge, unlocking immense opportunity and changing our relationship to our planet and to ourselves. Exploration is defined by our relationship to the frontier. Beyond the frontier is the unknown. We all need the unknown. It gives us a sense of mystery, that gives us imagination, that gives us purpose, that makes us human. So what would those great explorers of the past be doing today? Columbus, Shackleton, Amundsen, Yuri Gagarin. I don't say this lightly, but I believe they would be doing what you are doing today. Going beneath the surface, breaking what is just a mirror to the sky. You are our planet's most important explorers, and with that comes extraordinary responsibility. Exploration is a double-edged sword. It always has been, it always will be. Exploration and exploitation often go hand in hand. Discover something new and people will want it for their nations, for religion, for economic gain, for power, for wealth, for status. And look at what's there. Resources are there to be unearthed that will drive our economic development, potentially our sustainable economic development. The power of ocean data can be realized. Millions of new species are to be discovered that can propel human medicine. We are, for example, already using the chemical and biological materials from marine organisms in about 18,000 products, including anti-cancer drugs and others to fight heart disease, cystic fibrosis. But imagine how some of these unknown species can help advance medical microbiology, clinical virology, genetics, and biotechnology. Even the origins of life are to be found in the ocean. How will we deal with this new era of exploration? Will we be able to sustainably manage and govern the ocean? Or will we make the same mistakes again that we have done on land? I think this is what will ultimately define you and your limited time on our planet. We have a chance to get this right. So I hope we don't mess this one up. Exploration is never easy. Let's just look back at what those explorers of the past had to endure. So I just want to look at two of the challenges that are linked, funding and the story that is being told, and compare ocean and space exploration. As Earl said, we've been looking up when we need to look down. But space exploration gets billions and billions of dollars, decadal investment from governments. Ocean exploration barely gets a dime. Marine science, in most parts of the world, the funding for marine science has been cut. 75% of all new jobs in marine science are being recruited out of China. NASA's PR budget, I understand, NASA's PR budget is the same as NOAA's entire science budget for the year. Need to get those numbers fact-checked before someone calls me fake news. But since 2004, out of all the grants that have been provided from foundations or overseas development assistance from international organizations like the UN and the World Bank, less than 2% actually go into the deep sea. So let's look at this story. Why is this happening? The challenge, ocean versus space. Now, how the community and the space community are actually telling the story is something which I think we can learn from. Space, the story is often one of a very positive story. We're looking for new life. In the ocean, There's often a negative story about how we're killing the oceans, how the ocean is under threat. Space is triggering the imagination. The stories around the ocean are often linked to fish or food security. I was doing it already this morning. The stories around the exploration of space are mission-based. They're exciting. But around oceans is often ideas-based, about the idea of conservation or the idea of food security. The narratives of exploration are of space exploration are around exceptionalism, collective human achievement, compared to the ocean, which is politicized often, with a multitude of different agendas. The ocean often has a call to action. We need to do something. We need to protect something. With space, there's very little call to action. Anyway, on and on it goes. But ultimately, space is talking about, is looking forward and is inspiring us about a brighter future, positioning it with a future of technology and opportunity for us. So what can we learn? The Apollo missions, of course, space exploration, but also polar exploration, Jacques Cousteau's adventures, even Felix Baumgartner's jump from space. Each one was a gripping story, packed with human drama, incredible achievement, overcoming adversity and courage in the face of the unknown. They are all positive stories that speak to a brighter future. So what is our inspirational story of human endeavor that can capture the minds and the imaginations of a global audience? I believe that that story is the human exploration of the deep ocean. And that is where subs like these start to come in. Their transparent pressure holes allow us to witness people in the deep ocean. And that single thing creates the vital human link that connects us with the ocean, with the journey of exploration that we are undertaking. And that story works. Hello.
Somebody said the AC was too hot.
Too hot in here?
Someone said it was too hot.
Okay, thank you. It's now going to be a bit cooler. And that story actually does work. So on our first scientific mission to Bermuda in the Northwest Atlantic, we invited journalists to come and report on our research into the state of the ocean. We had a global audience of over 750 million. The BBC, PBS, Forbes, The New Scientist, Sky News, The Guardian, Telegraph, Sirius XM, on and on it went. They all came to report on the health of the ocean, but also through the lens of the human journey which we're on. The drama of original exploration with people at the center of the story provided that hook and the lens for new audiences to learn about critical ocean issues and build deeper understanding of the importance of ocean health, helping to give decision makers the public mandate that they need to act. I want to take you on a dive in our sub so you get a little bit of a sense of what I'm talking about. I'm a pilot, so has anyone been in one of these submersibles? Aha, one at the back. So you may remember the safety briefing which you were given before you dive. So as the pilot, the first thing I need to say to the passengers is that if I am incapacitated for any reason, which one hopes will not happen, then they need to understand how to bring the submersible back to the surface. The other thing is that in the pressure holes, we have an air supply, and if that air supply becomes contaminated, then you have to switch on to an independent breathing system. It's a bit like a diving regulator. We have communications to the surface. You need to learn how that acoustic underwater telephone works. And as a member of the sub-team, you've got to keep alert. There are all sorts of things down there that could entangle us, that could cause us problems. So let me give you a quick anatomy of the submersibles. To ascend and descend, we have ballast tanks, as I'm sure you're all aware of, and the ability to then create neutral buoyancy in the ocean. We have our battery pods and our thrusters for power, lead acid or lithium batteries. And we have variable levels of endurance depending on the missions. Inside the sub, we have our air systems, oxygen being pumped in, and a scrubber taking out the carbon dioxide. We have our communication system. We have a joystick to be able to go up and down, left and right, and translate, to be able to move laterally. And we have our control screens for our readouts on oxygen, our carbon dioxide, our depth, altitude, sonar. So you can control your music, of course. You need to have music in in your submersibles and your aircon. And so we adapted these submersibles for scientific research with an array of sensors and sampling equipment, including these extraordinary cameras. We worked in partnership with Teledyne Marine and Bowtech subsea vision equipment, and their equipment was at the heart of the mission. These high-definition cameras, the Bowtech Surveyor HD Pro, were deployed on the submersibles and were pivotal to our research that we were undertaking on the health, the function, and the resilience of the ocean. What was extraordinary for us was that your support didn't end there with the imaging systems themselves. With any Endeavour operating in hostile environments, with the great unknown environment of the deep ocean, problems will always arise. And solutions are found in partnership. And Teledyne Marine provided extraordinary levels of support, often at very unsociable hours, to ensure we maintained critical productivity throughout the mission. Here's a short video I just want to show you about what we achieved together. And that just captures the proverbial tip of the iceberg. And together, this is what we've achieved so far. But that was just the beginning. So I want to leave you with an invitation for you, for the businesses here, to find innovative new ways to work with more scientists. They need your help now more than ever. And I've set up the Necton Oxford Deep Ocean Research Institute, collaborating with the University of Oxford. We are a small innovation hub for marine research, with a goal to explore the deep ocean and accelerate our sustainable governance. To accelerate scientific discovery, we're investing in 3 major initiatives at the moment, one around ocean data, and for the last 2 years we've been building the largest database of harmonized open access data, which we launch next year. DNA. We're looking to build a DNA lab at sea that can be contained in a flight case using cutting-edge miniaturized sequencing technologies and making it replicable so we can give these DNA labs at sea to dozens of scientists around the world to help start mapping the ocean genome. We have an AI project applying the major investments into machine learning that's being made by driverless car companies to help automate the analysis of video data. And as you've seen, we also undertake our missions. Our strategy is to combine scientific research, ocean policy, capacity development, and public engagement and education to achieve the greatest coordinated impact. And this is where we're going to be going next, to the Indian Ocean. From 2018 to 2021, we're undertaking 6 expeditions across 6 critical different biogeographical regions. For pure exploration, it doesn't get any better. This is the least researched ocean on the planet. It is also the least protected and most at risk, with 2 billion people living on its shores and rising exploitation of marine resources and low awareness of the damage being done to biodiversity. So we have a range of different targets for this mission. It's obviously science-led as always. We hope to discover at least 1,000 new species, 600 science papers, creating a network of 18 areas with improved and sustainable management. We're aiming to reach a global audience of 1.5 billion, millions of students to be engaged with our submarine STEM program that will hopefully help inspire a generation. We and the scientific institutes that are here today cannot do this alone. We all need your help. We need the technologies that you have to explore the deep ocean, to understand how the ocean is changing and how that affects all of us. The sensors, the sampling equipment, imaging systems, mapping systems, on and on it goes. So I leave you with this invitation. If you're not going to join us, then please find scientific research institutes that you can work with going forward. I'll leave you with a short video, which you may, I'm not sure anyone's seen yet, but it's of our next mission. And I look forward to working with you in the years ahead. Ooh.
We are all explorers. When we see the horizon, we want to go beyond. We want to see what is there, why it is there, what it means to us, how it changes what we know, and how we live with our planet. And when we do, we move forward. It is time we took the next giant leap. The next great journey of human endeavor. It is time we went deep beneath the waves. The oceans are life, our life. And 95% of them remain unknown. It is time to discover the secrets of the deep, before the ocean's demise triggers our own. It is time for Neptune Mission 2.
Thank you very much.
Teledyne Marine. Everywhere you look.